Okay, so we're going to start working on something called Bernoulli's trials. Okay, named after James Bernoulli. So, one of these trials, okay, it can be classified as having two outcomes, success or failure. Okay, so for example, let's say I'm rolling a dice. If I roll a 3, I win the game. If I roll anything else, I lose. That's success and failure. Probability of success is rolling a 3, 1/6. Probability of failure is rolling anything else, 5/6. Okay, and that's it. So, there's more characteristics to a Bernoulli's trial and you need to learn them off. Okay, so for it to be a Bernoulli trial, you can only have two outcomes. Success and failure. Okay? So your outcomes need to be classified as two things, either a success or a failure. The trials are independent of each other. So the success of one can't depend on the success of another. Okay? And if they're independent, it means the probabilities aren't going to change based on the previous trial. So, the probabilities are constant from trial to trial. The probability isn't going to change. Okay? So if I'm picking, let's say, beads out of a box, in order for it to be a Bernoulli trial, the bead has to go back into the box because they can't be dependent on the first outcome. Okay? So I can't pick red and then that red's gone, so the probability will change for the next trial. That can't happen. Okay? So if we're talking about beads in a box, they have to be put back into the box because they have to be independent and the probabilities have to stay the same. Okay? And the last thing is there's a fixed number of trials. They tell you how many trials we're doing. Okay, so let's do a few examples. Can I get rid of the board? Okay, find the probability of getting a 6 on the 4th throw of an unbiased die. I suppose this is the very basics of Bernoulli. You don't even need to classify it as failure and success. But if you did, what's the probability of success? So that would be getting a 6, okay? So that's 1 out of 6. So what's the probability of failure? 5 out of 6. Now, I want to get a 6 on the 4th throw of a dice. If it's on the fourth throw, what happened on the first, second and third? I didn't get a 6. So I failed, then I failed again, then I failed again, and then I got a 6. Does that make sense to you? If I'm getting my 6 on the fourth throw, that implies I didn't get a 6 on the first, the second, the third. Okay, so I failed, and I failed, and I failed, and then I succeeded. What does and mean? Multiply. So 5/6 by...
So you just assume that...
Yeah. Yeah, you just assume that because I'm only getting a 6 on the fourth throw, that means you didn't get a 6 before that. Okay? So that's my answer.
Are you just assuming that this is the way that this is renewable, or how you said trial? Like they don't ask it in a certain way, like...
So I'll show you now. This is the very basics of it. So like you could have done that without knowing it was Bernoulli.
Yeah.
Okay? But now the next questions you're going to start, I suppose, getting more familiar with the way they ask the question, and then you'll know it's Bernoulli. Okay? Okay. Can I get rid of the board? Okay. So, right, we're talking about getting 3 heads when I flip 4 coins. Okay? 3 heads when I flip 4 coins. So the way this can happen is head, 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 tails, head, head, tails, head, head, tails, head, head, tails, head, head, head. But you're not going to do it all out like that. It's just going to take too long. Okay? So I have 4 coins and I want 3 heads. Can anyone tell me what I've done in the previous chapter that would allow me to get the number? How many choices have I? 4?
Choose.
Yeah, choose. 4, choose, 3. Okay? I have 4 coins. Okay, so 4, and I want 3 of them to be heads. So 4, choose 3. All right? Then the probability of head. Now, I just want to go back here and see. Okay, yeah. So it's a biased coin. And the probability of head is 2 out of 5. So what's the probability of tails? 3 out of 5. Okay, it's a biased coin. It's just so that it's clearer with this. So I know if I'm looking for 3 heads, it would be 2 out of 5 by 2 out of 5 by 2 out of 5, wouldn't it? This is doing it the different ways. So head, 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 tails, 2 out of 5, 2 out of 5, 2 out of 5 by 3 out of 5. This is heads, heads, tails, head. But all that's happening is it's 2 out of 5 by 2 out of 5 by 2 out of 5. So it's 2 out of 5 to the power of 3 and 3 out of 5 to the power of 1. And that can happen 4 different ways. And if I go to my calculator and I put in 4, choose 3, I get 4. That's the 4 different ways it can happen here. So rather than doing it all out like this, I can use the binomial. So remember binomial distribution from algebra 1. Okay? This is it here. Okay? N choose or, p to the power of or, q to the power of n minus or. Okay? Now, this is sounding all very complicated. It's actually so easy in a question. So let's just put down our binomial formula. Okay? So the general term of a binomial expansion is this. And we're going to use that, okay? Okay, an unbiased die is thrown 5 times. Find the probability of obtaining 1/6. Now, if I'm getting 1/6, that would imply I can either get 1/6 and then not a 6, not a 6, not a 6, not a 6, or not a 6, a 6, not a 6, not a 6. You're going to go through that, all those options. But we know to save ourselves time, we can just use this. Okay? So, n is the number of trials. So n is 5. Or is the number of successes. So, we're looking for 1/6, so or is 1. Okay? P is the probability of success. What's the probability of success here? A 6. 1/6. And Q is the probability of failure, which would be 5/6. And now I can just throw it into my formula. So I've 5 trials and I only want 1/6. So that's 5, choose 1. Success is 1/6 and I want it to happen once. Failure is 5/6 and it has to happen the rest of the time. So 5 trials, one of them is a 6, so 5 take 1, which is 4. N take or 5 take 1, which is 4. Okay?
Do you know what you're saying, like or equals whatever P equals, is that the same for all the questions?
Yeah, P will always be success
Yes.
and Q will always be failure. Yeah.
And is N the number of trials?
The number of trials and or is the number of successes, always, yeah. It's going to be more procedural. You'll get used to doing it over and over and you'll just throw it into the formula without needing to identify those things. Okay, so throwing that into my calculator, that's what I get. Okay, 5, choose 1, NC or, remember the button on your calculator. Okay, the choosing. Probability of success to the power of 1, failure to the power of 5, take 1. Okay, so that's 1/6. Let's do another. Same question, now it's the probability of 3 6s. Okay, find the probability of getting 3 6s. So, it's still 5 trials, 3 of them have to be 6s. 5, choose 3. Success is to the power of 3 in this case, and failure to the power of 5, take 3. Okay, throw it into the calculator. Is that alright? And lastly, find the probability of obtaining at least 1/6. So I've 5 trials. I want the probability of obtaining at least 1/6. So what am I looking for? 1/6 or 2/6. It's at least 1. So 1/6 or 2/6 or 3/6 or 4/6 or 5/6. That's going to take an awful lot of time. Could you reverse it or do the opposite? Probability of what? Not getting a 6. 0 sixes, exactly. And you're going to take that away from 1. Okay? So at least 1 is the same as 1 minus the probability of no 6s. Okay? So the probability of 0 6s is going to be what? How do I do that? 5 trials. How many of them are going to be 6s? 0. 5 choose 0. How many successes do I want? 0. How many failures? I want 5. Okay? So that's the probability of getting 0 6s. If I want at least 1 6, it's 1 minus that answer. So just take that away from 1.
Why are you taking away from 1?
I'm talking about probabilities. So the probabilities, if that's the probability of 0 6s, then probability of not 0 would be 1 minus that. Okay, all the probabilities add up to 1. Okay. Can I get rid of this? Okay. If I say to you, I'm rolling a dice, and I want the 4th 6 to appear on the 10th throw. The 4th 6 appears on the 10th throw. Before your 10th throw, what happened in the first 9? That's it. Perfect. 3 of them were 6s. It's going to be 9 choose 3. Okay? 3 of them had to be 6s, and then the 4th one happened on the 10th. So let's do an example like that. Well done. A card is drawn at random and then replaced. The process is repeated until the 3rd diamond appears. Find the probability that the 3rd diamond appears when the 10th card is drawn. So what does that mean before the 10th card? 2 diamonds. So that means 2 diamonds
Put a 9.
in 9 cards, exactly. And then for the 10th,
3.
what is the 10th card going to be? A diamond, and then a diamond. Okay? So you've 2 diamonds in 9 cards, and then you have a diamond, because the 10th card is a diamond. Okay? So 2 diamonds in 9 cards. That's going to be 9 choose 2. What's the probability of a diamond? A quarter. 13 diamonds out of 52, or 4 suits, one of them is diamond, 1 out of 4. So a quarter. How many diamonds did I want there? 2. And then not a diamond, 3/4. Well, if 2 of them were diamonds, 9 take 2 is 7. That's the probability of 2 diamonds out of 9. And means multiply. I need to get another diamond. Probability of another diamond is a quarter. Throw that into your calculator and you get your answer. Okay, so go on.
Why is it 2 diamonds?
Because the 3rd diamond has to happen on the 10th card. So that's the 3rd diamond. So before that, there's 2 diamonds.
What do you mean by 3rd diamond?
The question is, it's repeated until the 3rd diamond appears.
You need to get the cards together, don't you?
So like, you are flipping cards, you've 9 cards and 2 of them have to be diamonds. Because the 3rd diamond has to happen on the 10th card. So that implies before the 10th card you must have had 2 diamonds already. So that's where the 9 choose 2 is coming from. 9 cards came out but only 2 of them were diamonds. And then on the 10th card it says find the probability that this happens when the 10th card is drawn. It's telling you they want it to be the 3rd diamond on the 10th card. Okay, so 2 diamonds before and then a diamond.
And where did you get a quarter to 2?
This
The 2 come from that.
because it's 2 diamonds. So the probability of success is a diamond, which is a quarter, and I want 2 diamonds, so it's squared.
And then where you get 7 then?
So remember my formula, it was to the power of or, and this was n minus or. 9 take 2 is 7. Yeah. Okay, so you can just use your formula, or you can say I've 9 cards, 2 of them have to be diamonds, the rest have to not be. So 2 from 9. Okay? Yeah.
Is it only a quarter because the cards were replaced?
Exactly, because they were replaced. I could not use Bernoulli or the binomial if they weren't replaced, because the probability would change each time. And at the very beginning I wrote that the probabilities have to stay constant. Okay, so they have to be replaced in order for you to be able to do this.
So is that
Okay.
how you know it's Bernoulli when it says they're replaced?
Yeah. Generally it's this type of question they're going to ask. Okay.